evening, ladies and gentlemen. Welcome to the Hong Kong Convention and Exhibition Centre, and thank you for attending the Shaw Prize Award Presentation Ceremony 2018. I am Dudu Chen, your presenter for this evening.
Good evening, I'm Leon Ko. I feel much honored to be the Master of Ceremonies again for the presentation of this distinguished international award, witnessing the outstanding achievements of the Shaw laureates with top-notch scientists and scholars from various parts of the world.
The Shaw Prize is an international award established under the auspices of Mr. Run Run Shaw. The prize is dedicated to honor individuals regardless of race, nationality, gender, and religious belief, who have recently achieved significant breakthroughs in academic and scientific research or applications, and whose work has resulted in a positive and profound impact on mankind.
The Shaw Prize consists of 3 categories, namely the Shaw Prize in Astronomy, the Shaw Prize in Life Science and Medicine, as well as the Shaw Prize in Mathematical Sciences. Each year, the selection committees and the board of adjudicators ensure that the highest standard of the selection and adjudication process laid down by the Shaw Prize is kept.
Nomination commenced in September last year, followed by adjudication in the first few months of 2018. The results of the Shaw Prize 2018 were announced at the press conference held on 14th of May this year. 3 Shaw laureates have been awarded the prize, and tonight they are here to receive the honor.
To ensure the smooth running of the ceremony, may we request our guests to kindly switch off your mobile phones and any sound-emitting devices. Also, on the table are special souvenirs. Please do feel free to take one set at the end of the ceremony to commemorate the occasion.
It is time for the commencement of the Shaw Prize Award Presentation Ceremony 2018. Ladies and gentlemen, please rise to welcome our officiating guest, the Honourable Mrs. Carrie Lam, Chief Executive of the Hong Kong Special Administrative Region of the People's Republic of China. Mrs. Lam, please.
Invite the 3 Shaw laureates to enter the presentation hall. First, please welcome the Shaw Laureate in Astronomy 2018, Dr. Jean-Loup Puget, please.
We now welcome the Shaw Laureate in Life Science and Medicine 2018, Professor Mary Claire King, please.
Last but not least, let us welcome the Shaw Laureate in Mathematical Sciences 2018, Professor Louise A. Caffarelli, please.
We would now invite the acting chairman of the Board of Adjudicators, Professor Frank H. Hsu, to deliver a speech. Professor Hsu, please.
Ladies and gentlemen, welcome to the 15th Annual Shaw Prize Award Presentation Ceremony. The Shaw Prize was established in 2002 to honor international scientists in the fields of astronomy, life science and medicine, and mathematical sciences. The inaugural Shaw Prize Award ceremony took place in 2004. Tonight, at this first ceremony since the passing of Mrs. Mona Shaw, we remember with gratitude her fiery spirit that transformed a vision of honoring excellence into reality with the creation of the Shaw Prize. Together with Mr. Run Run Shaw, Mrs. Shaw forged an alliance of entrepreneurship and philanthropy, inspiring the quest for knowledge and highlighting outstanding achievements. A woman of great humility, Mrs. Shaw was a mighty force of progress, and her dedicated strength and energy continue to inspire her fellow council members in sustaining the Shaw Prize. Future generations will, under the direction of the Shaw Prize Foundation, continue to broaden the Shaw vision of advancing knowledge through scientific discoveries, thus strengthening and enhancing the aims of the Shaw Prize. Those of us who have been involved in the enterprise are committed to carry on Mr. and Mrs. Shaw's vision. Tonight, we honor 3 scientists in the designated fields of their distinguished contributions. They are Dr. Jean-Luc Pouget in astronomy, Mary Claire King in life science and medicine, and Professor Louise Caffarelli in mathematical sciences. Our thanks to the 3 selection committees, and I now welcome the chairman of those committees to introduce the laureates and their work.
Thank you, Professor Shear. Please take your seat.
We now invite the chairman of the selection committee for the Shaw Prize in Astronomy, Professor Reinhard Genzel, to deliver a speech. Professor Genzel, please.
Chief Executive, honorables, ladies and gentlemen, and dear laureates, humans look out into the universe in what we call visible wavelength. That's how we work with our eyes. We also are used with our mobile phones and with radio waves to receive much longer radiation called radio waves and microwaves. But in between this is a vast and very unexplored window to the universe called the infrared submillimeter microwave range. And it's a mysterious region. We know little about it. It probes cold, dusty objects, such as dense interstellar clouds, which in our galaxy and others form new stars. We can also see very distant objects as they were when they formed 10 billion years ago. And the longest wavelength in the microwave regime even give us information about the very early age of the universe, when the universe was only minutes to seconds to a few 100,000 years old, just after the Big Bang, through the cosmic microwave background. Now, to detect these faint signals, you can't just go and look. It's very difficult. You have to have very sensitive equipment to overcome the instrumental and thermal background and foregrounds. You have to go above the Earth's atmosphere to remove the disturbances of the atmosphere. So it's a technically very challenging waveband, which only recently has become developed and used for astrophysics and astronomy. The 2018 Shaw Laureate in Astronomy, Jean-Luc Pouget from the Institut d'Astrophysique Spatiale in Orsay in Paris, together with his many European and worldwide collaborators, have done a fantastic job in exploring this new waveband. Initially in his career, one of the themes he worked on was so-called interstellar dust. Now, dust is a nuisance on Earth. However, in interstellar space between the stars is a way to form new stars. And early on in his career, Dr. Pouget, together with another French scientist, Léger, and independently a group of 3 scientists, Alamandola, Thielens, and Barker, discovered a new species of interstellar dust, which are rings of carbon atoms, polycyclic aromatic hydrocarbons. It's like a bit like carbon, like outer soot in interstellar space. Again, you would think it's a nuisance, but actually this form of interstellar dust has given us enormously important information. So for instance, in the late 96 time period, using data from an American satellite, COBE, Dr. Pouget and his collaborators looked for a faint glow of emission in this 100-micron far infrared range to depict radiation which we now know for much more detailed observation since is the afterglow of the Earth's first galaxies which formed. Satellites like ISO, Spitzer, and Herschel from both NASA and ESA have given us detailed information on these early discoveries of Puget's. Now, the culmination of Jean-Luc Puget's work, building on his technical and scientific knowledge he has obtained, was the leadership of a very sophisticated and extremely sensitive instrument for the European Space Agency's Planck Satellite. Planck is a satellite in a series of attempts, both by the Americans, the Japanese, and also Europe, to explore the cosmic microwave background, both from the ground as well as in space. And between 2009 and 2013, Puget and his colleagues used this new instrument with very novel, very sensitive detectors to measure the back and foregrounds of the cosmic microwave background to incredible precision. And as a result, we now know enormous detail and precision about the early universe to a fraction of a percent in some cases. So to give you one very spectacular area of work, and that is the time when the first structures formed in the universe. We don't know how that happened, but there's a lot of theoretical speculation that this would be due to quantum fluctuation on atomic and subatomic scales, which was then amplified within a small fraction of a second after the Big Bang by a huge factor called the inflationary expansion into the pre-galactic and pre-galactic cluster scales, which we now know. And so this speculation, of course, is so important to know our origins that we are looking for it, and the CMB has information in it, and the HFI, the instrument of Puget's, placed very detailed limits on what kind of inflationary models we could expect. Now, we know since some time that the universe is expanding. In fact, it's not only expanding, it's expanding in an accelerating fashion. And so if Einstein's relativistic theory is correct, that must be because the vacuum itself has energy. That's very surprising. Why would that be? How can we explain that? Well, an alternative, of course, is that Einstein's theory is wrong. And so again, the CMB can help and look at the fluctuations of the cosmic microwave background radiation imprinted on us on its way from a great distance into us, and in fact has shown in that way in spectacular fashion that Einstein's theory is correct. Finally, as the cosmic microwave radiation moves towards us, it passes through time because of this finite speed of light. And as it does so, it also goes through a region when actually the first galaxies formed. We haven't seen those galaxies quite yet, but the CMB radiation gets some, imprint on it in its polarization, which the CMB can detect and thereby tell us where we have to look next to see this early phase. I could go on and tell you many more things. One thing is clear, of course, such research, very ambitious experimental work, cannot be done by single individuals. And many people, scientists, engineers, students, mathematicians have worked worldwide on, contributed to the success of the Planck mission as well as its predecessors. Yet Jean-Luc Puget's wide-ranging contributions and leadership in infrared and submillimeter astronomy really do stand out in making a fitting recipient for the 2008 Shaw Prize in Astronomy. Jean-Luc.
Thank you, Professor Gansel, and please take your seat.
We now invite the chairman of the selection committee for the Shaw Prize in Life Science and Medicine, Professor Randy W. Sheckman, to deliver a speech. Professor Sheckman, please.
Madam Executive Director, distinguished guests, and honored laureates, breast cancer is the only cancer that is considered universal among women worldwide. It is the second leading cause of cancer death among women. According to the American Cancer Society, breast cancer makes up 25% of all new cancer diagnoses in women globally. In 2012, nearly 1.7 million new cases were diagnosed worldwide. But great strides in detection and treatment have been made in the past 2 decades, especially one that we recognize this evening in the work of Professor Mary Claire King, this year's Shaw Prize winner in the life sciences, who discovered the genetic basis of some forms of breast cancer. King's journey to her breakthrough began in graduate school at the University of California, Berkeley, where she studied with Alan Wilson. Together, King and Wilson demonstrated the genetic similarities between chimpanzees and humans. They showed that these primates shared 99% of their DNA and suggested that chimps and humans evolved from a common ancestor. Before King and Wilson's discovery, many scientists were still doubtful of the relationship between chimps and humans. However, King and Wilson's genetic evidence supported the theory that primates have a genetic tie, which indicates a common ancestor. Back when King started her work in the 1970s, the link between cancer and genetics hadn't been made. The running theory at the time was that cancer was viral. King said, "I thought genetics, evolutionary biology, and statistics might add something to the newly launched war on cancer. And my closest childhood friend had died of cancer. I wanted to try," she told the New York Times in 2015. On her own, as a faculty member at Berkeley in 1990 and then at the University of Washington, King discovered that the gene BRCA1, or BRCA1, on chromosome 17 was associated with the occurrence of breast and ovarian cancers. Over the course of 16 years, King collected data from breast cancer patients and tested her hypothesis that some cases of breast cancer were genetically linked to BRCA1. Later, she also identified the gene BRCA2 on chromosome 13 as associated with breast and ovarian cancer. King found that these genes are responsible for expressing proteins of the same name, BRCA1 and 2. These proteins are known as tumor suppressors. That means they repair, in this case, damaged DNA in the cell and thereby prevent cancer. However, if these genes are mutated, then the proteins, the damaged proteins they produce, may not function effectively. And thus, if they are unable to repair damaged DNA, then a cell may become cancerous. King found that individuals with one of the inherited gene mutations had an 81% risk of getting breast cancer over a lifetime, whereas individuals without the mutation had a 10-fold lower risk of developing the disease. King reported that approximately 5 to 10% of all breast cancer cases are due to BRCA mutations. Her discovery allowed women to be screened for mutant forms of these genes and to become informed of their risk for developing these cancers. In addition to her seminal achievement with the discovery of the first breast cancer genes, Dr. King has made critical contributions in the application of genetic tools to uncover and resolve human rights abuses. Beginning in the late 1980s, in collaboration with the grandmothers of the Plaza del Mayo of Argentina, King identified their grandchildren who were kidnapped as infants after their parents were murdered during the Argentinian military dictatorship of 1975 to 83. Her laboratory assisted the grandmothers in the reunification of more than 100 families. In collaboration with the United Nations Forensic Anthropology team, Dr. King applied DNA sequencing to identify the remains of victims of extrajudicial execution on 6 continents. Working with the US military and the families of those missing in action, she identified the remains of US soldiers who had gone missing in Vietnam, Cambodia, Korea, and even during World War II. Her approach is now used by government and UN forensic teams worldwide. It has been used to identify the remains of an American serviceman who was buried beneath the Tomb of the Unknowns, Arlington National Cemetery, for 14 years, as well as victims of natural disasters and man-made tragedies such as 9/11. In 2014, Dr. King received a prestigious Lasker Award for her work in breast cancer genetics as well as human rights. And then in 2016, President Barack Obama acknowledged her work with the National Medal of Science. At the ceremony for this award, Obama said, "At the time when most scientists believed that cancer was caused by viruses, she relentlessly pursued her hunch that certain cancers were linked to inherited genetic mutations." Again, according to Obama, this self-described stubborn scientist kept going until she proved herself right. Tonight, we celebrate her courage. Thank you.
Thank you, Professor Jackman, and kindly take your seat.
We now invite Professor Timothy Gowers, Chairman of the Selection Committee for the Shaw Prize in Mathematical Sciences, to address the audience.
Good evening, ladies and gentlemen. Louise Caffarelli is the world leader in many aspects of the study of partial differential equations, a vast area which is of central importance to mathematics and physics, and also to other fields such as economics and biology. He was born in Buenos Aires in 1948 and studied there until he received his PhD in 1972, before spending the rest of his illustrious career in the United States. When we think about equations in mathematics, what comes to mind first is probably a statement like 2x plus 5 equals 11. Here we have an unknown number, x, and some information about it. And our task is to calculate x. With a partial differential equation, the unknown quantity is not a number, but a far more complicated object, such as a mathematical function that describes the future behavior of a fluid or many other physical phenomena. This makes finding solutions extremely hard. In fact, it is usually impossible. So the main focus is not on trying to find solutions, but on trying to prove that they exist, and on saying something about the properties of those solutions. Even this is very difficult, however. For example, it is not known whether the Navier-Stokes equation, which determines how fluids behave, will always have a solution that is valid for all time. I don't want to alarm you, but mathematicians cannot prove that the drink in front of you isn't about to explode. A prize of $1 million is offered for anybody who can resolve this problem. Amongst Caffarelli's numerous remarkable achievements is a famous paper written with Joe Cohn and Louie Nirenberg that is still regarded 35 years later as the biggest step towards solving it that anyone has taken so far. And it may reassure you to know that as a result of this paper, we know that if your drink does explode, the explosion will in a certain precise sense be a small one. And this is just one of many examples of what he has done. In general, his impact on the field of partial differential equations has been enormous and highly diverse. Rather than giving you a dry list of his achievements in the field, I would prefer to quote two other famous mathematicians talking about Caffarelli, because I think this will give a more vivid impression of the awe in which he is regarded by the community of mathematicians around the world. So here first is Alessio Feghouli, who has just been awarded a Fields Medal. He says the following: "While I was at the École Polytechnique, I was offered a position in Austin, Texas, where Louise Caffarelli, a very famous mathematician, was based. I always admired him so much that I thought this was an unmissable opportunity to learn from him. I was 25 back then, so it was the perfect moment for me to try the US experience. I spent 7 years there, and it was great. I learned so much there, and I learned so much from Caffarelli. And here is Louie Nirenberg. Fantastic intuition, just remarkable. When we worked together, I had a hard time keeping up with him. He somehow immediately sees things that other people don't see, but he has trouble explaining them. He says things and writes very little. So when we were working at the board, I would always say, "Louise, please write more, write down more." Once I said to him, "Louise, to use a biblical expression, where is it written?" Somebody said he once heard a talk in which Louise proved something in partial differential equations using nothing. Just somehow, out of thin air, he can come up with ideas. He's really fantastic. And we on the committee thought that too, and so we think he is a very worthy winner of this year's Shaw Prize in the mathematical sciences. Thank you very much.
Thank you, Professor Gowers, and please take your seat. The research findings of each of our Shaw laureates have undoubtedly made important and enormous contributions to mankind. The Shaw Prize is an international recognition and honor to them.
As a recognition and acknowledgement to the outstanding contributions of the Shaw laureates, each prize bears a monetary award of $1.2 million. Each Shaw laureate will also receive a certificate and a gold medal. We now proceed to the Shaw Prize Award Presentation Ceremony 2018.
Ladies and gentlemen, tonight we're much honored to have the Honorable Mrs. Carrie Lam, Chief Executive of the Hong Kong Special Administrative Region of the People's Republic of China, to officiate at the presentation ceremony. First, we will present the Shaw Prize in Astronomy 2018. The award goes to Dr. Zhang Puget.
What interests me is questions which are scientific but also philosophical. Origins of the universe, how the planets and the stars form, origin of life, origin of consciousness even.
We now invite the Shaw Laureate in Astronomy 2018, Dr. Zhang Puget, to deliver his acceptance speech. Dr. Puget, please.
Honorable Carrie Lam Zhang, chairs and members of the Council and Board of Adjudicators of the Shaw Foundation's Selection Committee, ladies and gentlemen, it is a very great honor for me to receive the prestigious Shaw Prize for Astronomy. And I express my gratitude to the late founders of the Shaw Foundation, Mr. and Mrs. Run Shaw. I also thank Professor Reinhard Genzel, Chair of the Selection Committee for Astronomy, and the members of the committee for the recognition of my work over 40 years. In astronomy, the long wavelengths from infrared to microwave were not much used until these last 40 years. The atmosphere blocks most of the radiation at these frequencies range, and furthermore, detectors and cryogenic instrumentation in space required technology which were only developed in this period. The space-based observations in this frequency range have been critical to my work and the results cited by the Selection Committee. The project I led, and especially the space experiments, requires the participation and talent of many scientists, engineers, technicians, in academic laboratories, in industry, and in space agencies. These projects were often dedicated to verify prediction of cosmological theories based on very general principles done decades before. Conversely, in galactic physics, I worked on too, which is often dominated by turbulence and chemistry, are more complex, and the observation revealed unexpected processes and were the guide of the theoretical work. When I look back to the 1970s, some of the far-reaching questions I worked on were already present. But I would not have even dreamed that we would built such sensitive and accurate experiments to test cosmological models, exploring the very earliest phase of our universe history. I am honored and proud to have contributed to lead parts of this amazing advancement recognized by this prize, and my thanks go to all those who contributed, and there are many. Thank you.
Thank you, Dr. Touchain. Please take your seat on stage.
Now comes the Shaw Prize in Life Science and Medicine 2018. The award goes to Professor Mary Claire King.
Cancer seems to me to always be genetic. But the question I asked is it ever true that predisposition to breast cancer could be passed from one generation to another?
We now invite the Shaw Laureate in Life Science and Medicine 2018, Professor Mary Claire King, to deliver her acceptance speech. Professor King, please.
Mrs. Lamb, dear members of the Shaw staff, members of the selection and adjudication committees, and especially Randy Sheckman for giving me such a lovely introduction, and fellow laureates and guests. It's a tremendous honor to have been selected this year to represent my field of life sciences and medicine for the Shaw Prize. To me, the Shaw Prize represents two features that I would like to share with you. The first is the internationality of science. As scientists, we are, I think, citizens of the world. It is perfectly compatible to be a scientific citizen of the world and also a very loyal citizen of one's own country. The truths that science enables us to discover together transcend geographic, racial, economic, and gender boundaries. They are fundamental and they are real. In that spirit, I would like to particularly thank my Chinese colleagues for their enormous help and support of me throughout my career. In particular, I would like to thank one of my dearest friends and longest collaborators, Ming Li, who is originally from Guangzhou region, has lived in the States since he was a teenager, and who brought me to China for my first trip in 1988. We taught a course together, and I will tell you a story about it. We were teaching together in Shanghai at what was then Second Medical University, and I was, of course, speaking in English. Our plan was that I would give a little bit of explanation of genetics, of statistical genetics in English, and then Ming Li would explain the same concepts in Chinese. This worked very well for 5 days. Then on the 6th morning, I gave an explanation of a concept, and Ming Li said nothing. And I thought, oh, this is excellent. Perhaps I have been so clear that everyone has understood. But no. Ming looked at me and looked at the class and said, there's really nothing I can do with this. You've got it all wrong. He was at the time just finished being a postdoc. So of course everyone laughed. The idea that the students did not understand English was clearly a myth. They understood that comment perfectly. So Ming was in the position of needing to explain from the beginning the complex concept that I had bungled so badly. He has been my support in my laboratory ever since, including throughout the project that led to the discovery of BRCA1. I would also like to thank my dear friend Rapchi Choi, who was, during a period of several years, the chancellor here at Hong Kong University, but whom I have known since we were both very young assistant professors. And we have been friends, collaborators, friendly competitors now for, oh gosh, it must be 35 years. So with these two guys as my friends and support, how could I miss? The second feature that I'd like to mention about the award and why I prize it so dearly is that It's an opportunity to offer from people from a very different field, namely from entertainment and public relations, encouragement to those of us in science. Encouragement across fields is, of course, enormously important. To me, it signifies encouragement as a virtue in itself. In particular, the encouragement that we as parents can offer to our children and grandchildren as they study mathematics and science is so important. Each of us laureates had the experience of our mothers and particularly our fathers being very encouraging of us when we were very small. So please, encourage your sons, encourage your daughters, not only to work hard, which of course as students in this city they will do, but to believe in themselves, to have confidence in their abilities, and to believe that their enthusiasm for doing science will serve them very well in the end, that it will be more and more fun for them, and that they will succeed, because they will. Thank you very much.
Thank you, Professor King, and please return to your seat on stage.
Lastly, we will present the Shaw Prize at the Medical Sciences 2018. The award goes to Professor Louise Caffarelli.
Computer simulation has developed new fields, but partial differential equations have been, up to now, what people use to describe phenomena from our daily life. There is a universality of these problems, and so it is nice because it is a constant challenge.
Last but not least, we now invite the Shaw Prize in Mathematical Sciences 2018, Professor Louise Caffarelli, to deliver his acceptance speech. Professor Caffarelli, please.
It's for me a great honor being awarded the 2018 Shaw Prize in Mathematics, particularly leaving its trajectory and its exceptional group of awardees. My professional life has been full of excitement and fulfillment thanks to many bright and generous collaborators, with whom I have the fortune to discuss and develop new ideas and discoveries, while often sharing at the same time the happy events of our family lives. Starting with my early mentors in Argentina that guide me through my early years shaping my vision of science. Next, my colleagues with whom we pursue many ideas and share failures and successes. And overall, my students and my postdocs that really brought constant energy and passion to our enterprise. At the personal level, I'm deeply indebted to the memory of my parents that surround me with care and affections all of their life. Also my beloved wife, Irene, that gave me her support and shared with me her love and tenderness for more than half of our lives. And to our sons, Alejandro, Nicolás, and Mauro, that fill our days with pride and joy. Jointly to them, my daughters-in-law, Elise, Camille, and Camila, and my grandchildren, Isabella and Luca. Finally, I want to thank the Shaw Foundation, not only for the award I'm receiving today, but for all the support it has given to the development of science, and in particular mathematics. Thank you very much.
Congratulations and thank you all laureates. We now invite the Honourable Mrs. Carrie Lam and Professor Caffarelli to stay on stage for a group photo. Ladies and gentlemen, the Shaw Prize Award Presentation Ceremony 2018 has now come to a successful conclusion. Scientific research has unbounded boundless possibilities. We look forward to seeing you again next year and to witness more accomplishments of distinguished scientists and scholars. Goodbye and see you all next year.
Thank you. Goodbye.